So this is the workshop called WTF. We know what that stands for. Is Kubernetes. Let me move into the slides here. So I don't want to talk too much about myself. The only thing I want to say in this slide is that the reason why I wanted to do this topic is because for the longest time, I was literally like, WTF is Kubernetes, you know, and cloud and Docker and all that. And push came to shove, started doing, you know, pen testing at work. So obviously, you know, you have to be able to know what you're doing. So I just fire hose, learned, you know, Kubernetes and a little bit of cloud stuff. Not as adept in cloud right now, but I studied to get my CKA exam, which is the Certified Kubernetes Exam or certification. So I passed that last week, yay. So that was kind of some validation for me that I know some stuff about it now. So, you know, I was just intimidated by all of this, especially cloud. Because I remember like years ago, I think I set something up, an instance, and I got charged $7. I was like, I got a bill. I was like, I don't know, I'm killing this, and it just, you know, it was just so intimidating. I didn't understand it. So definitely a late bloomer, but not anymore. So lifelong learner, in that I'm continuously, you know, wanting to learn new things and am doing that now. So let's get started. All right, so the way that I structured this workshop, and mind you, I only had a week to put this together because like I said, I was studying for the exam. I structured this the way that if I was learning this for the first time, this is how I would want it. Like the way I learn is give me the basics, show me how to do it, and I'll fill in the blanks on my own later and ask questions later. So that's how this is going to go. So it may move kind of fast through the slides, especially the first part where we're just talking through stuff. I'm going to spend more time on things that I think are more important to cover. Obviously, you guys can read, so I'll leave that up to you to read the slide if I don't actually talk about it in depth. Oh, before we actually get going here, I want to make sure that everybody is signed up on Google Console, because that is where we're going to be doing the last portion of the lab, and I don't want us fumbling around too much if we can help it. So you could do that while we're doing the talking piece here in the first 30 minutes or so. So yeah, let's get into it. This is what we're going to cover. Containers in Docker, Kubernetes. Then we'll talk a little bit about the cloud, and then we'll actually jump into the hands-on portion of each of these and end up hacking a vulnerable WordPress application hosted on Google Cloud. So this whole container Kubernetes concept was confusing as hell to me, be honest. And I'm going to do my best to break some of it down, but like I said, well, not like I said, but like I feel like things will click once you do the hands-on portion. So just bear with me as we go through this. If it's just like, if your eyes are starting to glaze over, I feel you, trust me. So just stick with it. So containers, what is a container? So here it says it's a package of software that includes all the dependencies. So basically, if you are familiar with virtual machines, which I think most of us are, you know how you have like an OVA file that you can like pass around a whole virtual image, right? Everything's in there, and you could pass it on to somebody. You know, like we've done in a lot of workshops, we say import this OVA. You're presented with like a vulnerable web, a vulnerable operating system, or whatever it is. It's similar. So containers and VMs are similar. The only difference is, or one of the differences is that, and actually that's in my next slide, is how containers are configured. So these are pretty much the same slide here, these two. Hardware, in this example right now, hardware is my laptop, right? My Mac laptop. Operating system is Mac. I have Docker installed. So Docker is considered a runtime engine. And then well, we have 3 apps here in this diagram. So there's no OS necessarily in this package per se, like it is in a virtual machine. So, you know, it's got everything in it. Like I could go pull down a Docker image and it's just gonna work. And that's really the beauty of Docker images. So once again, in this image, in this example for virtual machine infrastructure would be my laptop. Hypervisor would be VirtualBox. That's considered a type 2 hypervisor because you also have bare metal, which is type 1. So let's look at this green. That could be like my Kali distro, right? One good thing about like Docker 2, like there's Kali images, there's vulnerable machine images. So like if you're doing a CTF, you know, we always have issues with our laptops. We haven't done a workshop where there's never been someone that has no issues. So great way to spin up a Docker instance and use it for your CTF or whatever, and then you shut it down. There are some caveats that you need to know. So there's no persistence data. So when you shut it down, your data's gone. So like if you're saving your scan files or something, they're going to be gone. You can set it up to have a persistent volume. So that is an option. And let's see, so like another, and this is virtual machine, I could have like, I don't know, Windows here, and then whatever else in app3. So that's virtual machines. So back over here in containers, once again, you know, my laptop, Mac, Docker, and then I would just have each Docker image loaded up as a container. And this will make more sense once we get into it, but great for portability. It's fast, lightweight. Oh, another caveat to Docker images, because they're meant to be small and portable, fast, you know, there's no GUI. So like the Kali Docker image, if you pull that down, it's like bare bone. And it took me a while to figure that out. And that's one of the reasons that we're going to be using Parrot, which is similar. It's another pen testing distro, but it has some of the tools we're going to be using on it. So, you know, there's so much out there. Let me see. All right, I want to move on to the next slide here. So, yeah, okay. So Docker, what is Docker? We got containers, right? These are the images that run in containers. Like you build your container from an image, a Docker image. So what is Docker? Docker is a technology for automating the process of deploying those containers. Okay, so it's considered a runtime engine. There's others out there, but Docker is the most popular. So, you know, it can run on servers, laptops, virtual machines, as we're going to see in Google Cloud. They actually have their own product called GKE, as do the other cloud providers. And the way you create Docker images is like Lisa me, I could build a Docker image. And I've actually got some experience doing that for work because we had to pen test on an environment that doesn't have internet access. So I couldn't like pull up a Kali image and download the tools. I had to do everything offline. So I had a Docker file, which is just a file. Actually, I wonder if I, well, I'll show you one online. So you put all the files and the commands in the Docker file, you push it up to Docker Hub, which is the registry, and now other people can pull it down. So we have public and private. And if you're like, for instance, I created a private one because like we were going to bake in like our Nessus license, right? So I can't make that public. So whoever has a link to my private repo could download it from there. So actually, I do have it up here, hub.docker.com. So this is Parrot security, Parrot OS, which is, like I said, it's the same thing as Kali basically, but they got their own little spin on it. I actually like it. So this Docker file, you see what this is basically it. So this is what it's doing to create the Docker image. It's gonna, this is like you know, just some basic info. It's gonna apt-get all these packages, do what it's gonna do, and when I'm pull this down, this is already gonna be done. It's so beautiful. I'm a big fan now that I've learned about Docker and Kubernetes. So hopefully you will be too. All right. And then, so I have Docker push here. So you're going to push it up to the registry. And then when you create a container, it gets pulled down. So you can actually just say pull and not run it, or you can just say run, which will pull and run it. All right. And I'll explain a lot more once we get into the hands-on portion. Yeah, so there we go. See if there's anything else I want to say about this. Okay. So quick and dirty intro of Docker. So Kubernetes. Kubernetes is an open source container orchestration platform. So it works with Docker underneath it, right? Still using Docker images, but now with Kubernetes, you can manage multiple containers, auto scale. There's so many features. It's really cool, which makes sense why people are using it in the cloud, because you have double, like, you know, benefits of scalability, and, you know, if things crash, you can that's what the self-healing is here, auto heal, auto scaling. You can change your configurations without having to pull down your image. So I pulled this right off the Kubernetes page. You're welcome to read that at your leisure. I'm just going to see if there's anything I wanted to point it out specific. Yeah, there's multiple vendors. So I mentioned Google and GKE. Most of the other big cloud providers have their own product for Kubernetes. Yeah, okay. Like I said, I'm going to move fast through these slides because I want to make sure we get through it, the hands-on portion. So let's look at, can you guys see my screen okay? Let me actually make it big here. Okay. This is a standard image of what you're going to see online for a cluster. So that's what they're called. You can have multiple clusters depending on the scenario. Like we're talking like commercial, you know, organizations. But this is a generic model of what we typically see of a cluster, especially in lab and learning environments. So what we have here is a master node. Okay. The master node is basically the admin for your worker nodes. So these green ones are worker nodes. This is where the applications will run in these pods. Okay. And you see here, there's certain components on each of the worker nodes. So kubelet, and actually we have some, I'll talk about this in the worker node slide. But so for master node, let's go back to master node. We have the API server, we have etcd, controllers, and scheduler. So this is typically what's going to run on every node. There's some extra things that folks will have, like logging and monitoring applications. But this is really it. Okay. I blew out the master node, which is also called the control plane, just so you can see it a little better. And I'm going to dive into this a little more in a couple of slides here. So I'm not going to read through this, but the one thing I did want to point out, these are components, those things that were on that master node slide. Kube API server is what we talk to. When I say talk to, when we run our commands, we hit the API server, and the API server says, okay, let me go do what you're asking me to do, right? I think I heard in the talk, it's like the maitre d'. They go and just do stuff, whether it's getting the status or creating a pod, creating a service, those types of things. So I just wanted to mention that. That's like a key piece here, just for FYI purposes. So worker node again, we have our components for worker node. I thought I had, oh yeah, okay. So the kubelet is what talks to the API server right here. So that's on every node. They're basically saying, hey, API server, is there anything you want me to do? And they go do it. Okay, the container runtime engine is Docker. So underneath Kubernetes is Docker, because we're pulling Docker images into making these pods. And I'll get into the pods in a second here. And kubeproxy is like handles like the networking piece, communication between nodes, pods. Okay, let me move to this slide. So I talked about the components of, I had the darndest time grasping the concept, and it's pretty, it's well known that this concept is confusing, but I worked through it and I'm going to explain to you guys what it is. Okay, so we have our cluster here, right? So this white piece of this slide is my laptop, right? And you see me here in my command line. So like I said, this is the tool, the command line tool called kube control that we will run to hit the API server, which does things in the cluster. Okay, so the cluster is like a logical thing. Oops. And the master, all the nodes are like virtual machines. Okay, and then you have pods, which have containers. And the containers are apps, you know, because you're pulling the Docker images, which are apps, to make a container. So that's why I was confusing. I was like, what? Okay, so the bottom line is it's usually a one-to-one, one container per pod. So that's why we have the drawing like this. There are times where you would have more than one container in a pod, but those are for special needs like this, you know, we got to start a process first before the actual application can run. So there's things like sidecar containers and init containers. All right, so but for today's purposes and what you need to know now, one app per container per pod. Okay, so this is kind of a drawing of what we're going to be dealing with today. We're going to be dealing with a vulnerable WordPress app. Parrot OS is, like I said, a pen test distro. nginx is a web proxy server, web app server, lots of functions for that. We'll be playing, just running some examples with that. Now, I need to mention imperative versus declarative. This example is for creating a pod, which we're going to be doing a lot of. That's a big part of what, well, when you're learning anyway, which you're going to be running. So these two commands, they do the same thing. You can do, you can run things declarative, which means I'm saying run this file. It's a YAML file. It's called a manifest file. So this is exactly what this would do. This is the imperative command. So we're doing everything command line, although the declarative way is command line, but it's pulling in the file. It's running from the file. And I think we'll do one example of that. Gosh darn it. Okay. So that's just a FYI. If you're asking what's the difference and why you would use one over the other, imperative, it's like you're testing things out, whether it's for personal or development purposes, but you want to use declarative eventually, because that is like your version tracking, your source of truth for the configuration of whatever it is you're deploying. So you'll see that all over the web of why you should use declarative to run your resources. So a couple topics here. The ones in pink are what we're going to be covering today. So kube control, like I said, is the command line tool, which runs against the clusters. Namespace, those are logical partitions. So think like, let's see, like in hotels, where you have two rooms that have that door that separates, but you can if you get two rooms, you can like have it unlocked and go between them, right? So that's essentially what a namespace is. Each room is a namespace, and you only get access to the other room if you have access to it. But it's really to separate out, teams or functions. And we'll create a namespace. It's very easy to do. Replica set is the primary method for managing pods and replicas. So basically, replica set is saying, oh, I have to make sure we're running 3 pods at all times. That's my job, essentially. Okay, and we will see how that works in the lab. Deployment is the declarative way of managing pods. So all these things get kicked off the replica set, deployment, and the pod. They work together. So it says declarative because, like, for instance, I could go in the YAML file, the config file, right, and say I'm going to change the number of pods to like 10. And replica set is going to say, oh, you set this to be 10. I got to go make 10 pods now. And we'll see that live here in a few. It's really cool. Daemon set is basically a way, if some things need to be run on every node, this is the tool that you would use. Service deals with networking endpoints. So we will see that live on the cloud portion, because we can't do it in the online playground we're going to be messing with. All right. Storage volume. So once again, when you spin up your pod, the data is not persistent, meaning that pod shuts down, which not that it's expected, but if it is, it should spin right back up. So if it happens, that data is gone. So that's why you have storage volumes, persistent storage volumes. So those are mounted like to a Google storage bucket or something, or you can have multiple types of storage volumes. And stateful set, I haven't played around with this too much, but I guess it's when you need several pods that need to run in parallel, but they have to have a specific identity. There's a concept of labeling. So you could say pod label X, spin up a pod or whatever according to the labels. Okay, so that was pretty fast, right? All right, let's move into cloud. And really now I'm going to gloss over this because Dominique did a presentation earlier today, which was really good. So hopefully you guys attended that, because this is a natural segue and it helps me out. But once again, cloud, like I said, I was so confused. I was like, isn't it just running on so many servers? Yes, but it's the combination of what it offers. That's the understanding I have. So, yes, it's in the cloud. It's in servers, on servers, but it's the way it's being offered and the way you access it. So there's literally massive data centers around the world. And they, your data can be sitting on multiple servers, which is why you should feel comfortable that your data is still retrievable with certain settings, in case, like, worst case, like what if a data center like blew up or something? There are other data centers around the world that have your data. Pay-as-you-go pricing. So you only pay for what you use. And I'm not getting to the specifics here of each service. I think, like, if you have a private IP, they charge you for that. I think the transit of maybe, I think it's uploading data to a bucket is what they charge you. I'm not really sure about that part, but it's pay as you go. So you can gauge how much you're going to spend depending on what service and products you use. Secure, and I say with caveats, that's because there's expectations that every cloud provider has built the service securely, meaning the hardware, the infrastructure, storage, identity services, network communications. And, you know, with that being said, the caveat is just like in on-prem, developers, system administrators are the ones configuring certain things, right? So if you misconfigure something, that's not Google's problem or Google's fault. You know, that's your fault, your company's fault for misconfiguring. I meant to pull up an example for you, like Tesla. I don't know if you heard that they got hacked because their Kubernetes dashboard was misconfigured. And, you know, while cloud is cool, I think there's a learning curve because there's a lot. I'm not even gonna lie. So I'm still, you know, learning as we go. You know, I'm looking to get my certs in that next too, but there's a lot going on there. And these are some of the benefits. Like I said, you can read these. Lots of benefits though. I think, you know, being in security and tech for 20 something years, that this is going to be like, you know, y'all need to learn this, just at least to know, to have that conversation, you know, at work and in meetings, because I foresee, you know, a lot of companies moving to the cloud. Not everyone can for whatever reasons, compliance, sensitive data. And we'll get into the differences here in types of cloud. So I'm trying to get through these slides a little fast here. So public, basically what's available to the public is what we're going to be using today, owned by third-party orgs such as Google, AWS, Azure, pay-as-you-go pricing. A private type of cloud is dedicated to a single organization. So like we're on a government version, so that's considered private. On-prem, so for like I said, there's reasons why you wouldn't actually want to go public, put your organization in the public realm. And then the hybrid is a combination. So I know you could have like, oh, I'm not gonna say who, but like you're split, you have some stuff in the cloud and then you have some stuff on-prem, and they can still sync, like Active Directory can sync between the two. So it just depends on the situation and how the infrastructure folks are configuring that. Service models, SaaS, PaaS, IaaS, SaaS apps are in the cloud, G Suite, Gmail, these types of things. Platform as a service, not really my area. Basically, development platform for you to work on in the cloud. So these are some of the apps: Google App Engine, Cloud Foundry. Infrastructure as a service is essentially you renting your IT infrastructure in the cloud. So the concept is that, you know, you're renting and now you have less costs up front. You just access your information or access your infrastructure, right? Knowing that you're giving so much trust to these cloud providers, essentially, that they've configured the underlying infrastructure securely. And now you have to configure everything on top of that. Shared responsibility model. So the orange here is the cloud service provider. So this kind of reiterates what I was saying. You know, for example, software as a service like Gmail, G Suite, you don't have any responsibility for that stuff, right? What am I going to do? Go and configure the server? Like, why? It works. That's what I signed up for. Just give me my Gmail. So this shows the you know, who's responsible for what. So you is considered the company or you know, organization. The orange is the cloud service provider. So that's the basics of that. All right, where are we on time? 32. Okay, we need to jump into this. So we're going to be playing on this playground here. So click the link or go to it. If you have the PDF version of the slides, those links are clickable. And, you know, I'm going to move at the pace that my computer is running. Like I said, we have little time considering what all I want to cover. And after this, I'm probably going to be like, oh, I forgot to mention this. Oh, if somebody can remind me to talk about Vagrant at the end, that's another way to spin up a VM, like you're doing CTF or something. Okay, so let's get to our playground here. Let me refresh. It says 10 minutes, but did it refresh? I've clocked an hour on this, so if it times out, just refresh your screen. So this website is really cool. They have lots of lessons on here, official and unofficial, because anybody can create lessons on here. There was too much of a learning curve for me to do it in the time that I had to do it on here, but we're still going to use it. So theoretically, if you were doing some of their lessons, you can just click, but we're not going to do that. So you just move this to the side. So you see, I clicked the Docker command, which means it's already installed on here. So what we're going to do is just run through these commands on the slides, and I'm going to talk through as applicable. So the basics. Okay. So let's type in the first command. We're going to say Docker run hello world. Oh my God, I can't type. All right, so a couple things here. Remember, so run, I got to keep my mind on Docker right now. So for Docker, so the way you pull down an image or run an image, and I may use these terms interchangeably, image, containers, pods, okay, but hello world is getting pulled down from Docker, okay? So if you go to Docker Hub and say hello world, oops, it's pulling right from here. Like, you see, I could have done this command and it would have done the same thing. Oh, you have tags. So if you wanted like a slightly different version of the image, you would put the tag like so. I would do like Docker hello world and then 12.1 or whatever it is. Okay. So this application, this hello world application, all it's meant to do is download and say hello from Docker. That's kind of the test that you see when people when you're learning Docker or installing it for the first time to test that it works. So we've successfully pulled down this hello world image, it ran and it stopped. Now, something else I wanted to point out here. It said unable to find image locally. Oh yeah, by default, right here it says latest. If you don't specify the tag, it's going to pull down the latest. So was I unable to find it locally? So it's pulling it down from Docker Hub, and that's pretty much it. Now, if I run this again, actually, I'm just trying to stick to the script here, but it would be local, right? Because I've just downloaded this image to my machine or to this website's machine. So if I do Docker images, you see now it's here, 13K. This is a really small one. And actually they already have some on here. They have Alpine, Ubuntu, and Redis. So I guess that was kind of a starter thing. They already pulled down some Docker images. I've skipped over, but let's pull down the parrot image. So Docker run, because I want to show you something with this -it -name. If you don't put a name, it'll just, I'll use the default name of it, but I'm going to put a name, name or whatever, my parrot. And the image is parrot sec/security shell. You see these? These are called layers. So in the Docker file, I forget at which point, but they're layers. So that's why when I go to download it again or spin up a Docker image or a pod, it doesn't necessarily need to download the whole thing again, which makes it even faster, right? It's really cool. So it's pulling this down. It might take a few. So what I actually wanted to explain on this part right here, this command, the -it is essentially saying like run interactively. It's dealing with the standard in and standard out. But furthermore, let's move further. I want a shell. That's what this is saying. At the end, this is putting a command. It could be anything, but I'm saying give me a shell. So you have to run interactively to do that. So this is a pretty simple command. Kubernetes commands or kubectl commands are very similar, just slight syntax difference. So it pulled down is almost 2 gigs, but it has an extract uncompressed it. So that's the beauty too. It's just, I'm telling y'all, it's really great. The portability and the quickness of how to you just spin stuff up, especially if you're doing home labs and stuff. You don't have to worry about messing up your local laptop. Although, I mean, if you're already using like virtual machines, it's not an issue. Let's see if there's anything else. Oh, since I have time here, the vagrant thing. So remember I said when you pull down most images from Docker, they're not going to have a GUI, so that's called headless. And for most reasons, you don't need to have a GUI because GUIs are pretty hefty in size. So another option, and I'm talking in context of like for your home labs and stuff like that. Vagrant is similar in that they're vagrant images. They're called boxes. You could pull them down from their registry, and like the Kali one, you pull it down, you say vagrant up, and it spins it up in VirtualBox, and you're ready to go. That's another cool thing. All right. So let me clear the screen. So what we have here, the reason why I wanted us to do this in Docker too was because we're going to be doing this on the Kubernetes side. So we are inside of the Parrot distro's image. So when you say shell like that or bash at the end, it's giving the command to the image, right? So this put us inside Parrot. So now, you're doing your typical commands, right? Just in case you don't believe me. All right, so this is the Parrot image. We're inside. Now let's open up a new tab because I don't want to get out of this. If we get out of this shell, the image is going to shut down. And I don't want to do that quite yet. So let's open up a new tab. And I'm always trying to be aware of what's going on when you're running images. So like I said, Docker images, we saw, we pulled down these 2 images. This is where they will be for you to see them. Docker PS shows you the running Docker containers. So because it's still running, I could see it in Docker PS. Okay. Docker, what do I have on here? PS-A shows you all. So we can see here that Parrot status is up, right? And the hello world exited 7 minutes ago because it did what it had to do. So some other commands here, if you want to stop the container, you say Docker stop and the container. So I'm going to say, I'm just going to copy, paste. So this should actually kill my shell. Let's go back over here and watch. And it should give me back a regular prompt. Because now I'm out, I'm going to be kicked out of the image. Okay, I'm back at my regular prompt. Okay. we can start it back up. So you just say Docker start in the container ID. And if you do a Docker PS minus, actually, oh yeah, okay. So yeah, because it's running, it should show there. But we don't have a shell, right? So how are we going to get the shell back? So this function, this command here, Docker exec, you have to do interactive again. And you should, I should just be able to say my parrot. So this is the command. That didn't work. Oh, yes, it did. Okay. Can parrot. Am I still on? I think my Wi-Fi wigged out. Am I still on? Oh, okay. All right. So tab completion is not working. Okay, so you see we're back in parrot. And we're going to close this out, this portion of the lab. So get out of it, and I want to remove these images. While they're not as big, you know, they're taking up space on your hard drive or somebody's hard drive. So let's see, Parrot was about 5 gigs. Hello World was small, but let's just go through deleting some of these images. So you could say Docker, and mind you, the container has to be stopped, or you're going to get it's going to scream at you, because remember the image started the container, right? So you can't remove the image if this container is still running. So Docker RMI removes the image. So let's say RMI hello world, since we know that one's, oh, there's the message. Okay. I could just cheat. We could just cheat and use the force flag, but we're going to stop the containers. So you put your container ID. Yeah, this should work. Oh my God. Why is it? Not sure why the container stopped, right? I usually just do the force flag. So what you could do is do Docker RMI-F. I'm gonna say hello, because we're doing this in like development. So that's what you'll get. It's deleted. So if you do Docker images, you see it's gone. So that's the basis of Docker. That was very like, you know, quick and dirty, but that's all we need to know for right now. I see, I'm looking at the screen and I see there's a lag. So I'm gonna wait for it to catch up. Okay. So what I want to do now is move on to the Kubernetes portion of the lab. And, you know, this PDF is a step-by-step walkthrough. So if you miss something or are planning to do this live later, you should be able to just copy paste everything and do everything that I'm doing now on your own. So don't fret. Okay, so we're in the Kubernetes section. So let's pull up our playground. Now, there's a link. This is not the same link as the Docker one. It's a different playground. So make sure you're on the right playground. It's on this slide here. Kubernetes commands one has the link to the Kubernetes playground that we're going to be using on slide 29. You don't have to say start scenario, but sometimes I do launch, sometimes I don't because it's already running. So this is the view of the master node. Remember I said it's called control plane. That can be named anything. The folks that created this called it control 1 and node 1. So we are actually on control the master node at this point. So these are the things that I typically do when I get going. Like I said, I always like to be aware of my environment first before I start hacking at it. Hopefully you are too, or you do too. So alias is a way to create shortcuts. And actually, if you just hit alias, you can see what, I guess they put this in here maybe already. So I'm gonna make a shortcut because I'm really impatient. And I don't feel like typing everything out all the time. So Cube Control is the command line tool. It's already installed on here, but I don't want to type it out. So I'm just going to say assign it to the letter K. So when I hit K, it's like I'm running the actual command. Okay. Clear. Now, this command here, oh, I skipped one, but hold on a second. The source kubectl completion. We're not going to do that. It doesn't work on this playground. But what that does is set the auto completion, because you know how you can hit tab and it fills in the rest of the command for you or shows you what's available to pick from. That's what this command will do. So you could skip that. API resources is a way to see all the resources. So this is pretty much what Kubernetes consists of from our point of view. Okay, and you can see here short names. I live by short names. So I will probably be using short names, but I think in the slides, yeah, I spelled everything out. So you're welcome to use either or. Maybe for practice learning, you type everything out. But the way I'm going to type it is shorthand, and you'll see what those are then. But you could always go back here and see what the short names are. Okay, I'm clearing the screen. It sucks that I can't move this node terminal out of the way, but that's okay. Okay, what's next? So cluster info. This will tell you the information for this particular cluster. We're only running one, so it's only going to show me one here. So it's running at this IP address, which is actually our node IP. 6443 indicates that they're running a secure version of the API server. There are ways that I think by default now, after a certain version, they made it where you can't run insecure without specifically doing that. But in older versions, that is a way to start enumerating if you're doing like a Kubernetes pen test to see if that's set, and that is definitely a finding. So first thing I do is look that up. I want to know the version. So I do short because it spits out less information. So the client is the kube control version, and the server is the Kubernetes API server version. Okay, it's more important. Well, especially for pen testing, you want to see if it's what version it is. But when you're not that we will be upgrading the cluster, but that's something that's important to know when you're upgrading the cluster. So we're going to look at this config get context. I need to speed up. Okay. So when I ran cluster info, pulled that information because that's the cluster I have access to. Get context shows me the context of what I'm running as, what user, what cluster, and it's actually pulling from this file right here. If we just cat, we can just cat it. Should show us. So the kube config file it's just a configuration file, which is usually in the home directory in the .cube hidden directory. So let's just cat this out and see what it looks like. So we have our certs, and we'll go to the top here, right? Certificate authority, the IP. If I had like another account, it would be in here. Because when I run kube control, it's looking here. So the access is here. So it says, kube config file, can she run this command against this cluster? So whoever's giving you access to the cluster will give you most likely a kube config file to put on your system to run kube control commands. Clear screen. All right. So nodes, talked about nodes. I'm shorthanding this again. So this tells me what nodes I have available in this cluster. We already know this because I mentioned it earlier that we have control plane, which is the master node in this case, and a worker node called node 1. Okay. I usually just do that to get a feel for what I'm working with. I like to do get all. This gives me all the resources that are alive in the context that I'm in. Right now, this is just a default Kubernetes service that's showing. You can also do like -a, which is also the same as doing --. What is it? All, see, I don't even use the long version. All namespaces. You can just do big -a. So this is a lot. When I first saw like some videos, I was like, WTF. I'm telling you. Okay, so I want to break this down as much as possible. Replica sets. I'm working from the bottom up. These are all my replica sets. There's 2 of them. These are my deployments. These are daemon sets. Okay, service, armor services, and pods. Now, if you haven't noticed, it's showing the namespace as for most of these as kube system. Kube system is a namespace where the control plane components are usually put or installed to. So that's why when I did a -a, I'm seeing all this, right? Because when I didn't, and I just did regular, I only got this. Just because I haven't created any resources in the current namespace, which by the way is default. Like that's literally the name of it. We could see the namespaces by doing K8S, or if you type it out, namespace. Oops. Okay, get namespaces. So these are all the namespaces that are currently configured. So like I said, default is usually what you're going to be put into, especially running labs. But from an administrator's perspective, like they would create different namespaces. So just showing you how that's done. Okay. So let's move on to the next slide. And keep this going. What time is this over at? So it's 2 o'clock. I think we're doing okay on time. Cool. Now, let's start creating some resources. So for this, I'll just talk through this real quick. We're going to run an nginx image, and I didn't have to put Docker here because it knows, like I said, Kubernetes by default uses Docker images. Okay. So this is the syntax. Run. This is the name I gave it. You have to do -- image and put the image name. So let's go ahead and run that. And this is going to create a pod, basically. This is the basis of creating pods. Okay. So I'm just going to copy this. Now, it says pod created. So the way you would, just make sure I follow my thing. Okay, we're going to get describe. Okay, so it said pod created. Now you could say get pod, but Lisa likes to do K and get all. Just I like to see everything happening, which will show the pods. Okay. So this nginx image is running in a container in a pod. Okay, remember I said one container per pod typically. So, and I'll be using those terms interchangeably, but now I'm going to start saying pods. Okay, so I have an nginx pod running. Now, if you want to see more information about this pod, you could say K describe. What am I describing? A pod and the name of the pod. Okay, lots of info on here, so I will talk through this. Okay, so this is the name, right? Default is the namespace. If you don't specify, puts it in a default. This is the node, so it's actually living on this node, which is technically a different virtual machine. What time it started, labels. This is the pod IP. By the way, pod IPs are dynamic. So if you remember me saying that pods, go up and down all the time, those IPs will change. Okay, so this is the container inside my pod. Okay. Hopefully this is starting to make sense. So we see that it pulled down this Docker image. That's the idea of it. So we only have one container. If I had multiples, there would be another section right underneath here that would say, like, I don't know, if I put a BusyBox container in here, which you can do. All right, what else do I want to mention? Pods will mount the service account to the host automatically in this path. var run secrets Kubernetes IO service account. You can also have that mounted externally or to a different storage volume. So that's what this is indicating, the volume. It's pulling that from here. So a secret is actually a resource for like passwords, that type of thing. And let's see, down here we have some logs. So under events, I didn't put this in there, but you can say K get events which shows you logs from that perspective. Or you could say K logs and then the pod name, which was what? What I named the pod? My nginx. Okay, so here's some logs from that perspective. Clearing the screen. Okay. So when I did a K cube control get pod, this is all the information I got about the pod, right? Basic information. I did a describe to kind of see more information about it. I saw the IP address of the pod, but if I do a kget pod -o wide, that gives me more information. And O wide can be used against other resources. So now you see I have some extra columns here with more information. So now it's telling me the IP address of the pod and what node it's on. Okay. So actually, that's why I put it this way. So let's copy this IP. This is the IP for that nginx application, right? So just to test, we'll say curl IP address. And this is the typical welcome screen you get for nginx. Welcome to nginx. You'll see a lot of examples using nginx to test, creating a pod and whatnot, or to test a service. So I hit the pod, it works, great. So I think that's all. Oh no, so leave that pod up. Let's now create a pod using Parrot. Okay, so go ahead and copy or type the command. I'm gonna name this one Parrot. I wanna interact with it, or do I? Yeah, because I wanna, I'll tell you a second what we're gonna end up doing. What is it? Parrot sec -security. And I want a shell. So kick this off. This takes a couple of minutes. So let's talk about what this command does. Remember in Docker what I said? Same thing here. I'm going to run this image called Parrot. I named it Parrot. I need to interact with it because I want a shell. So one cool thing you can do, if you open up a new tab, you can watch this live. So let's just say watch kubectl, which you have to type out. And I'm looking at, let's look at the pod. So you see it says container creating. So this is running every 2 seconds. So we can actually watch this live. When it's done, I should have a shell over here. So what I want to do is we're going to go inside Parrot and we're going to curl that nginx pod, that application. And this part is really just to show you that the networking piece is so simple. This is something that is supposed to work out of the box. Pod to pod communication. Okay, running. So there's my shell. I know you guys believe me, but I'm just going to tell you one more time. I'll show you one more time. Let's see, looks like tab completion is working here. Okay, so I'm inside Parrot. Now, what was the IP again of that? Oh, to get out of the watch, you just do Control-C. I need that IP. Okay, so nginx was this IP. So back in my other tab, I'm going to say curl. So I'm inside a pod, then I'm hitting another pod. and it works. Okay. So this is confirmation that works. That's really what I wanted to show in this particular portion. So why don't we yeah, I think we can delete these. Actually, I want to show you something. This is something we're not going to be able to do, like I said, but you can delete these pods, but I just want to show you how to create a service, because this is how you would do it. So you would say, I'm going to create a service, theoretically now, for nginx to be accessible from the interwebs. Okay, so, okay. So I would say, K, expose this pod named my nginx, and I want to create a load balancer. Type equals load balancer. So what we'll see when we get to, that's not right, what I miss. Why is this not working? Did I miss something? Oh, forgot to put the port. So theoretically it will be on port 80. All right. So I'm saying expose this pod to the internet, right? And what we'll see on the GCP side, these work great together. GCP will create a load balancer for me. Give me a public IP address, and I can hit that from anywhere. This won't do it, as I said, but this is how you would see. You see it says pending right here? It's not going to work though. So on GCP, it takes like a minute to get your public IP, but this is how you would do it. I also have on here node port, which means this pod could be accessed outside of the cluster. So instead of load balancer, I would say node port, and that's the only difference. Now, I'm going to delete these pods. So you would say K delete pod, you put the name. I think you could do this on one line. Delete both of them, my nginx. Yes. Okay. So we're going to play around with what we're going to be doing in the cloud. So I'm going to go back to the first terminal here. And this should, there, it ended. Clear the screen. So we are on slide 31 right now. So let me talk through what we're going to do here. We're going to create a namespace called my namespace, just so you can see that it's that easy to do. We're going to create a vulnerable, a pod of a vulnerable WordPress container in the namespace, the new namespace we just created. We're going to list the pods. Oh, what you're going to see here though, is that this pod is not showing. And that's because we did not set the correct namespace, right? Because we created it in this namespace. And remember the hotel analogy, I cannot get to that other room unless I have a key. So you have to specify, and this is the assumption that we have access, which we do at this point, because this is a lab. So now you have to say get the pod in the namespace, and then we're going to delete that pod. And then we're going to create a deployment. And I'm going to, once I create it, I'll talk through. It'll be easier to understand when you see it on the screen. So go ahead and let's run through this first portion of slide 31. Okay. So I'm creating a new namespace. You can name it whatever you want. There's my shorthand, my namespace. Okay, let's look at the namespaces. It's there now, right here. Great. Now, let us create this vulnerable WordPress pod / application / container. Okay, so we're gonna do a K run. I'm gonna call this my WordPress, my WP. The image we're using is gonna be EY. Oh, you know what? I forgot to mention something. I'll mention it here. EYS. I'm just gonna copy this. So this is somebody's repository on Docker Hub. There are precautions that need to be taken when you are pulling down images. Because remember, somebody created that image, which means they could have embedded some malicious code. So you are best to look at what the image is doing. Now, the only reason I'm trusting this is because, I mean, I'm like 90% trusting this because they created it from, it's like they forked it, like, right? They created from this image that's already out there by WP Scan, and they're a legit organization. They also created the WP Scan tool. So I'm okay with downloading this this image. So it says pod created. What do we do? Let's get pods. I'd like to see, oh no, I did not put the right namespace. So what do? We have to say -n and the namespace that we spun it up in. Now it's showing. All right. Same thing for actually anytime you do anything with these resources that are in a different namespace, you have to put the namespace, which is good. Like that was the whole point, right? I don't want you accidentally doing stuff in a namespace that you weren't supposed to. So I'm going to delete this pod now. So K delete pod, the name, my WP, specify your namespace, and the pod is deleted. You can scroll up. Oh, this doesn't have scroll up. Okay, get PO dash. All right, it's terminating. So it'll be gone here in a few. Okay. I want to move on to deployments. And I'm just going to create this first one because it'll be easier for me to show you what it does. So copy. So the command is a little different now. We're creating, before we were just creating individual pods. Now we're creating a deployment. So what does Lisa like to do? Get all. Okay, look at all that. So first thing it does, it creates the replica set, right? Only one copy or one pod is desired. Then it rolls into deployment, and then deployment. So these work together essentially. So where's my pod? Oh, here's the pod. Here's the pod. So when you spin up pods this way through deployments, it assigns a random name to the base name. Yeah. You know what? I should delete that service. So one of the cool things that Kubernetes does is auto scale, or you know, if there's like a demand, a high demand on a web app, and the settings say when it reaches this CPU or memory level, I need you to spin up X amount of pods. And if the demand dies, I need you to bring it down. So you can see how that could be a cost saving to an organization. And not just because the resource is being used, but because man hours. This is done automatically, you know? So something cool here, we're going to scale this deployment up to 20 pods. And y'all, once you see how fast this goes, you know what, before we kick it off, go on your second terminal there and do a watch on get all. We're gonna watch this live. Oh shoot, that's right. You have to spell it out. kubectl get all. So it's refreshing every 2 seconds. So we're gonna scale this deployment up to 20 pods. We only have one. I've got people hitting my website. I got a crazy sale going on. We need to spin up more pods to handle the load, right? So the way you do that is scale. What am I scaling? A deployment. So this is shorthand deploy. What's the name of the deployment? My nginx. And gosh darn it. How many replicas do I want? Replicas, I want 20. Now let's switch over to the watch. Oh my God, look at that. That's a lot. Maybe I should have said 10. But you get the gist. It's creating these pods like nothing. All right. So if you think of this in the cloud and how the cloud works, right? Like as far as resources, like the VMs themselves too can be scaled. So these working together, it's just like it's like so great because the resources are a lot less. The automatic piece of it, yeah. So I don't know if you can't tell, I'm a fan. Let's keep the watch running. Okay, so we are watching a get all in the second command. So let's spin it down, guys. Let's spin it down. Let's do 3 replicas. So I wish I could up arrow. I'm just gonna copy this. Let's change this to 3 pods. Switch over to my second tab here. And now you see they're all terminating, right? All but 3 will terminate. So back to the point about data, you know, if you had any data in any of those pods, it's gone, unless you have a persistent volume mounted and attached. All right. Okay. Lastly, I want to delete this stuff. Now, I'm not going to go individually and delete each pod. Where am I? Over here. I'm not going to go here and delete each pod and the deployment and the replica set. All you have to do is delete the deployment and it takes care of what is deployed. It'll delete everything. It won't delete the service. That's something separate. So we'll actually do that manually. So all you got to do is say K delete. What am I deleting? A deployment. What's it called? My nginx. And that should do it. Did it work? I have it. Oh, where did I mess up? My not pod deployment called my engine. Did I typo it? Oh, there, I must have had a typo. Okay, so actually I left the watch up. You can see, dang, I didn't even have time. It already deleted everything. I'm going to delete the service just because it's bugging me. So the way you would delete is we delete everything else. Delete, what am I deleting? A service. The name is called my nginx. So if I do get all, for example, I'm back down to having the default Kubernetes service, and there's nothing else here. Okay. Now, one last part of this is you can create resources. Well, I told you this already, through YAML files, through the manifest file. And this one that we're going to do just happens to be online. So that's kind of cool. This is an official Kubernetes demo app, if you will. So copy the command. So we're saying create this deployment from this manifest file, the deployment.yaml file. So if we were to look at that, we could actually see all of what's going to do. And I think actually, I'm going to pull it down. I thought I did before, but so feel free to run that. I'm going to pull up the YAML file here so we could see what it's actually doing. Desktop. Okay. So look familiar, right? It's a little different because this is a deployment. The other one that I showed you in the slides was a pod, but this is the basic format of a YAML file. So you would have your API version, kind, metadata, and spec. Here, if I had this to that 20, the replicas, it would have spun up 20 pods. The other thing I want to point out here is the name. The name is called, actually right here, sorry. The name is called nginx deployment, whereas in the other example, I said my nginx, so they named it nginx deployment. It's pulling this image from Docker. The tag is 1.14.2. Okay, so let's run that if you haven't already. And run a watch if you'd like to see what all it's doing. Let me clear screen. Okay. Oh, it's already still watching. Okay. So if you remember in the YAML file, it said 2, right? So that means replica set says, oh, I need to make 2 pods, deployment, they work together. And up here are the pods, the 2 pods. It's great to see the status is running because a lot of times you will have like different types of errors and then you got to figure out why the pod is not working. Sometimes you typoed the image, or the repo is wrong, or there's a lot of different reasons why you would get error messages. But I feel like, I don't know, I feel like Kubernetes is fairly easy, medium easy to learn. It's kind of siloed to me. So that, I don't know, I like it. So I would encourage you guys, if you're not even, if you don't want to take the exam, but learn some basics, it just kind of opens up your mind of how things may be in the very near future. So what do I have here? So this is actually nginx deployment too. So again, why don't we test it out? We can say, get pods, I need the IP address. I'm gonna do a -o wide. You can grab either one of these IPs, it doesn't matter. And the kernel should work. Yes, it does. Okay. So we're actually seeing that application. Now, how are we on time? Shoot. Okay, we need to move over to the lab in GCP. So hopefully you can, we're done with this playground. Okay, so moving on in slides. Hopefully you guys have set up your Google Console. So what we're gonna do, I have a blank slate on my account. I have a second account in a different browser that's got all this done just in case we run out of time. I'm just gonna talk through it and y'all can watch and follow along on your own. So for now, hopefully you've created your console account. Click this link. These guys right here created a cool CTF, a Kubernetes CTF, and we're gonna cheat and use their script, their setup, just because it's easier. But I learned a lot of things from this one too. And at the end, if you still want to play around, you can actually play with their CTF. So what you need to do, I guess I'm gonna do this with you. So where are we? I'm going to click open in Google Cloud Shell. And like I was saying with Docker images, for any script that runs, you should be, you should look at what it does first before you go installing stuff. I checked it out, it's legit, so. All right, so this is gonna clone their GitHub repo. All right, into our GCP instance. Essentially, we're going to get prompted to create a project, which is first and foremost of what you need to do. And then the script will actually set up our Kubernetes cluster. So if you are at this point, you should just do a ls and run the setup. I just hit enter for the default project name. This web shell is for their CTF. So you can just put anything here for now. If we have time, I'll explain how they set theirs up. But essentially, they already hacked their vulnerable web app, and you know the hacker. This is the scenario. The hacker hacked it and sold the web shell to the vulnerable compromised web app, and that's the shell that you get to move forward in the CTF to practice hacking Kubernetes. We're actually going to go through hacking the vulnerable web app. So this part takes a while. Let's see what else we can talk about. So yeah, let me just talk through some of the other slides. I have a feeling I might need to walk through. We're done at 3, right? 3. No, we should be fine. We should be fine. We're going to be right at the edge, actually. So let me continue configuring my own instance in case I have to. Crap. Just walk you guys through it. Oh, was this already? Never mind. Okay, I'll shut that up. So I set that up. Sometime your shell will die. You just open up a new tab. We're not there yet. I'm just mentioning that. And you lose your alias. All right, the cluster is still getting set up, so I just gotta wait it out. What happened to my other? Okay. So Marcy, I'm not sure why. Make sure your pod is still there. Get the IP with the O wide. Get the IP and then do the curl. I don't know if you're doing it from inside the pod or outside, but both should work. I mean, I'm complaining about how slow this is, but it theoretically is fast, right? It's faster than like having to install it from scratch. I told you guys I have a patience issue, so I'm working through that. Let me see if there's anything else I wanted to mention that I didn't mention while waiting here. I would like some feedback because you know, I had to throw this together in a week, and I know it's been kind of rough. I think I need to cut some stuff out because this is probably could be an 8-hour day workshop, but I want to make this better, so I wouldn't mind getting some feedback on this. And if there's something more specific that you would have liked to have seen for me to talk about, that would be helpful. All right, it's almost done. Let's see. I'm kind of mad at myself that I took this long to learn it. So for those of you that, if you've taken OSCP, this is not as hard. I had to take it twice. You get a free retake. So I took it again the week after, which I realized I needed to study up on some stuff, but it's, I think you know, hands-on type exams obviously show that you know how to do something. And for those of you that know me, I have my opinions about certifications. So Marcy, I don't know. Maybe we could screen share later and I could see your setup. Yeah, my goal, Mary, was to alleviate some of the scariness of like, I don't even know, you know, like what? That was my whole thing. So if somebody showed me this, I probably would have learned this a lot sooner. Because you know, it's not as scary. Like if you remember the first time you guys saw an output from Nmap or like Wireshark, you're like, whoa, right? Same thing here. I just needed somebody to talk me through things. And so hopefully, that's what I wanted to do here, is not teach you everything about it, but show you like some real world application of using Docker Kubernetes in the cloud. Okay, back to here. You can see all the resources that it installed. So those should look familiar, some of them anyway. Where are we? So we need to install a couple nodes. So if you're at this point, you need to select your project that it was created. There's your cluster. Click on your cluster. Let me move this shell down. And if you click nodes, I only have the one node, but I want to install a couple more nodes. So this is how you do that. So you can name it anything. I'm gonna say my pool. I'm gonna say, give me 2 nodes, create. This will take a couple minutes now. And really, you can just walk through the slides and do these commands. So I'm creating a couple extra nodes, and then I'm going to install that vulnerable WordPress app in a pod. We're going to make that accessible to the internet. So theoretically, anybody could hit that WordPress app and hack it, but we're going to be shutting this down here in a few, so don't worry. Okay, so, oh, did the node finish? Nope. Where's the refresh? Let me go back to, oh, you know what? I wanted to walk through all this in the cloud, but I think Dominic did a great job on the cloud workshop. So hopefully you guys saw that. You know, it's your dashboard and you have all your products over here. I have these pinned because these are the ones we're using the most. So you have your cluster. So this is GK. You have your workloads, right? So these are the applications that are deployed. You'll see Parrot and my WordPress pod here. The services. Once we create that load balancer to hit the internet, you'll see that here. And you know, this is a great way to learn what's doing what, especially the networking is it can be confusing, especially this cloud, the cloud version. I'm still like iffy on certain things. I just haven't had time to really get into it yet, but that's the gist. I mean, you got everything's over here. This is your project home screen. I always look at billing too to make sure you know what my billing looks like. I actually have a budget set, so in the case that I leave stuff running, it will alert me that I set it at $10. Okay, so getting back over here, I want to see if my nodes are up. Actually, I could just do a git node. God dang it. Alias kubectl. Okay, we have 3 nodes. They're in the ready status, which is great. I'm going to now install the, we did the 2 nodes. All right, I'm gonna install the vulnerable web app. Oh my God, vulnerable web app. And you know what I would do? Because it's taking so much time, I would open up a new tab, Cloud Shell tab, and run the Parrot as well. Install the Parrot pod. So first, oh, wrong. Where are we? Okay. So this is my WordPress instance. I'm going to open up a new tab and run the Parrot which again is like Cali. I think I have to do alias on this. Okay. Let me just open another one. I feel pressure. 40. Okay. We're not going to make it. I think I can whiz by this. Because we only have 10 minutes. Okay, I'm going to switch over to my instance, my other instance that's already up and running, because I'm just going to talk to the rest now. We're out of time for us to walk through it together. Okay. I'm sorry about that. It's a lot. Now I gotta find it. But yeah, I did it in Firefox. Okay, my shell's still up. So we're at the part where I've installed both VMs. I have my load balancer up, which I need to get the IP. Do I have it? Oh, it's right here. So this is the public IP. I'm going to pull it up in a browser. Okay, I'm at the admin portion of the WordPress instance. So right now, imagine you have your admin hat on versus your hacker or pen tester hat. So we're setting up WordPress, my site. I'm going to say admin, 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 just for demo purposes, admin at mysite.com. Install WordPress. You know, there's a lot of vulnerable WordPress instances on the internet. I'm not going to log in because I don't need to right now. So what I'm going to do, I've already exec'd into my Parrot instance. So I'm in Parrot. I'm going to do a WP scan on this URL. So I'm using WP scan, the tool, to scan this WordPress instance. What? Oh, I didn't copy it to my clipboard. Okay, we don't need all that. Oh my God. Let me do this a different way. What's the IP right here? So I'm going to scan that instance. Why did it do that? Stop. Oh my God. Let me just copy from the slide. So this is what I'm doing. A WP scan. I'm going to put my IP in here. So this is the command we are going to run. Okay, back in Parrot. Luckily, this doesn't take that long. And I've already created a word list. For some reason, the Parrot didn't have the word list that it said it's supposed to have. So I just created a small word list and put the password in there that I set for WordPress just for demo purposes. So you can see that it works. Let me change this to. All right. WP scan is finished. Real quick, let's look to the results. We see the Apache PHP version. This header is interesting. I would definitely look at the robots, and if you do, you'll see a folder there, but it doesn't actually take you anywhere. This is, I don't know if it's a plugin. But that is exploitable. XML RPC, you can DOS. What else is on here? So all these that came up. And of course, in a regular web app pen test, you're going to do, NICTO and manual enumeration with like burp. Okay. But this is what are the tools you would use too if it's a WordPress site. Okay, we're looking at all these things that found. 2015 is an old theme. It's probably vulnerable. What do we have? Well, obviously the WordPress version, that's tells me I could probably exploit this that way. These are config files. That is not good because usually config files, you can just pull it up too. This is not a pretty view, but it shows, passwords and usernames, stuff like that for the database. Okay, anyway, moving down, you see, it found admin username. So my next command, which I've already copied, gosh darn it. Let me go back to the slide. This next command here, I'm going to use my word list that has the password in it because I purposely put it in there. Okay, so I'm going to rescan it with the password. With the word list. Shit. What is going on? Oh, you know what? It's in the root. I think that's why. Am I missing something? Oh, I have three tags here. Let's do that. I feel rushed. Okay, we're gonna get through this. We're almost there. Oh my God, seriously? I called it word list, that's why. And I can't up arrow, so this is making it even worse. But finally, all right, the scan is kicked off. Okay, I'm cheating, but because I'm telling you guys everything now, but it found the username and password, great. Let's log into the WordPress with my newly found hacked creds. It's gonna say update, that's fine, whatever. So at this point, you have access to the box this way, but I want a shell. One of the ways you can upload a shell is through the theme, the PHP files. And the way I did it for this lab was we're going to use this bash shell. You can use any shell. So what you would do is just copy it all. It's PHP code. And where is my thing? Oh, I'm just going to put at the top here. And you hit save. And if you go to I'm trying to get to my browser. Let me get the IP. Okay, so if you browse to this path to hit that PHP file that we put our backdoor or our shell, we should get it. Okay, we got it. So this is a different kind of shell. I thought it was kind of cool. So you see here, the command line is down here. So if I do ID, we're cmdub data, right? Right. You can run commands here. Oops. It's got some funkiness to it, but that's real life stuff. You got to figure that out anyway. How to bypass if your shells are not working right. So this is what the OS that WordPress is running on. It's a Ubuntu machine. So moving forward, what can we do? What else can we do? Yeah, I said we're not root. So at this point, you would try to do some privilege escalation. There's lots of ways you could do it, but I wanted to close out showing you guys the metadata service, which each cloud provider has. They're trying to lock it down. but the metadata service is per, shows the info, like the metadata per that instance. And it passes certain information back to your shell, which is how it can authenticate too. So just putting this one in here in the shell. And if you notice, I have the trailing slash at the end. It'll list the what other stuff is here. So if I just say v1 slash, and I can keep going, right, to drill down what else is showing here. So to cheat, I just wanted to show you a couple things like this token. No token? Why? That's weird. Oh, I did not copy the whole thing. For Google's metadata service, you have to have this header piece, just FYI. So you see the token here. So I can use that to try to hack this box. Cube env. I mean, I didn't even drill down into that v1 beta one. So all this information, this is crazy. Okay, this is crazy how much information you get. But at this point, you have lots of options for privilege escalation to get root on the box, and you basically own this box right now. So that's how one way you can compromise Kubernetes in the cloud, and thus somebody's cloud account. So that is it. I'm sorry I had to rush through this last piece. I think are we at the end? What I do want to say is I'm happy to answer any questions. You can email me. I don't mind. Let me put my email. But I would like some feedback, just because it's like, I know this needs work. So that's me. Yeah, that's pretty much it. So thank you guys for joining. I hope you got something out of it. If anything, I hope you're not scared like I was anymore. All right, so they haven't kicked me out of Zoom yet, so yeah, well, if you have any questions, I guess you can put them there or email me directly. Oh yeah, there you go. Okay. So with that, guys, I hope you're enjoying the con. I think it's going well. It's pretty cool. Finally, we got this kicked off after all these years, and I hope to see you guys around. Thanks.